I'm going to walk you through a few IV gravity drip rate calculations. We're going to start off really simple, and then pretty soon it's going to become obvious that there's a nice trick you can use to help you do these calculations quickly. We'll start off using the ratio proportion method. We can discuss dimensional analysis after class if you want to. But hopefully you won't need really to rely on either method once you understand how this is all going to work. You know that IV tubing comes in macro drip and micro drip. Micro drip is always 60 drops per ml, and we'll talk about that separately. Your macro drip tubing, you'll notice, is 10, 15, or 20, all numbers that go into 60 evenly, and just kind of think about that and tuck it away in the back of your mind, because we're going to discover something as we're going through this process. Okay, so let's start solving our problem. We have an order for normal saline at 120 mLs per hour. We have a tubing set that is 10 drops per ml, and we want to know how many drops per minute we have to count to keep this hourly rate. So let's start by converting from 120 mLs per hour to mLs per minute. Oh, sorry. Excuse me. 1 hour has 60 minutes. Okay, so cancel those out. Multiply across after you've canceled those out to milliliters a minute. And if you want to take a minute to look at that, we can probably pause it. But just so you understand, we have 2 milliliters per minute. Now we want to know how many drops per minute. So we have to convert that. So let's get our drop factor out here. We have 10 drops per milliliter. Milliliters cancel out. 20, multiplying across, 20 drops per minute. And that's our answer. Okay? And we're going to change up the problem a little bit. Let's get rid of it first. Okay. And this time it's going to be even simpler. We have an order for normal saline at 60 mLs per hour. Same tubing, 10 drops per ml. So let's start 60 mLs per hour. Hour is 60 minutes. Using ratio and proportion, we can cancel these out. We can cancel those out. So we have 1 ml per minute. Doesn't get any easier than that. Now that we have 1 ml per minute, let's use our drip factor tubing. Okay, mLs cancel out, multiply across, 10 drops per minute when your rate is 60 mLs per hour. So let's get rid of that. So now our rate has changed to 30 mLs per hour, and this might be like a keep vein open rate. Same tubing set, 10 drops per ml. At this point you should be getting ever so slightly bored. 30 mLs per hour. An hour has, hold on, 60 minutes, we know that. So cancel this, cancel that. And we end up with 1/2 or 0.5 ml per minute. And down the bottom here, 0.5 mLs per minute times our tubing factor, 10 drops per ml. Cancel that. And multiplying across, you end up with 5 drops per ml. So let's start to look at what's going on here. When our order is Don't forget to capitalize your L. Our order is 120 mLs per hour. With this 10 drops per milliliter tubing, we end up with 20 drops per minute, right? When we have a rate of 60 mLs per hour, we end up with a rate of 10 drops per minute. When we have 30 mLs per hour, we get 5 drops per minute. Now some of you might be starting to recognize a pattern here. We're using a set that has 10 drops to an ml. 10 goes into 60 6 times. If you look at the pattern here, when we have an hourly rate with this 10 drop set, we end up dividing by 6, which is the number of times that 10 goes into 60. 60 minutes in an hour, you're kind of getting the point. So let's see if this works when we have a 15 drop set. Okay, so let's take a look at this problem. We're back to our original order of normal saline at 120 mLs per hour. Now we have macro tubing with a drop factor of 15 drops per ml. Well, let's see what we can do with that. We're going to go back to our original conversion. We want mLs per minute. I'm going to go through it really quickly because at this point it should be pretty simple. And we haven't changed anything here. It's still 2 milliliters per minute. What's going to change is the new tubing. So 2 milliliters per minute times 15 drops to an ml. mL still cancel out. We go across. We end up with 30 drops a minute. Well, that's interesting. Okay, so let's see how that plays out in a few more problems. So let's practice that again. We have a new order for normal saline at 100 mLs per hour. Same macro tubing with the drop factor of 15 drops per ml. I'll go through it kind of quick. As I said, at this point, it's probably getting pretty old. We have excuse me. All right, so now we can cross multiply, go across. We have 25 ml per hour. Now, if you're looking for a pattern, you might see one, but let's do one more just to see whether this holds up. So now we have an order for 60 mLs per hour, same tubing, 15 drops per ml. And handwriting's getting a little sloppy here. We have 1 ml per minute. 1 ml per minute with a 15 drop set is 15 drops per minute. Okay, so I know I went through that pretty quickly, but I think everyone should be catching on at this point. And let's just recap what we ended up with. When we had an order for 120, we had 30 drops per minute. When we had an order for 100 mLs per hour, we ended up with 25 drops per minute. And when we had 60 mLs per hour, we had 15 drops per minute. Now, using the same logic we used with the 10 drop tubing, you can easily see 15 goes into 60 4 times. And when we do the ratio proportion, the long method, we end up with a drip rate that is 1/4 of our hourly rate. So dividing our hourly rate by 4 gives us our drops per minute. And that's another quick way. Now you can also use this for 20 drop sets. We've seen that 10 goes into 60 6 times. We divide our hourly rate by 6 to get our drops per minute. We've seen that with a 15 drop set, we can divide by 4 because 15 goes into 60 4 times. So if you have a 20 drop set, just using that same logic, you can divide your hourly rate by 3. And I encourage you to set up a number of problems along the way and investigate this for yourselves. It's going to be true every time. It's just what happens. So now you can kind of move on to some more complex problems. So now let's solve a problem with a number that isn't evenly divisible by any of those factors. We're going to solve for normal saline at 125 mLs per hour, which is actually a fairly common order to find because it will infuse over 8 hours. You'll get a 1,000 ml bag. And so this is fairly common. If you have a 15 drop set, you can't divide it evenly by 4, but you will get something with a remainder. It's really not any more difficult than what we were doing. We'll do it the long way in ratio proportion. So we have 125 mLs per hour. An hour is 60 minutes. We're going to end up with a rate of mLs per minute of 2.08. Not exactly the most even of numbers, but let's go ahead and plug that in anyway. So 2.08 over a minute times 15 drops per ml is going to give you a rate of 31.2 drops per minute. And for that, you'll probably need a calculator. Now, here's what the problem is. You really can't count drops in fractions. It just isn't possible. Unless you have some kind of bionic eye that I don't possess, you are not going to see 8/10 of a drop or 2/10 of a drop or 4/10 of a drop, and certainly not 0.3333. So you need to round to the nearest whole number. Again, we're talking about basic 4th grade math here. So if the number you come up with, let's say, for sake of argument, you come up with 21.8, you round up to 22. If your number is more like 31.2, you're going to round down to 31. It's really not that complicated, but that's basically how we solve for gravity drip rates.